Alright, so what we're going to be looking at here today is optimizing well layout, scouting, and design using LIDAR data and CAD mapping. What we see here on the screen is a large map set of dispositions from sustainable resource development for a large area between the Whitecourt to Fox Creek to Valley View area. And what we're looking at today is to lay out a hypothetical well somewhere in the vicinity, say here of the Fox Creek area. Here's the town of Fox Creek. We take a look at the mapping that we have available. This is Pembina Pipeline Terminal, and what we're going to do is we're going to look to put a well adjacent to this Apache lease right here. Looking at the aerial photography, we can see that we've got a bush-covered area here. This looks somewhat low, or potentially rather, this looks somewhat low. This is higher ground, and we want to locate a lease somewhere in here. Now, going to this AutoCAD file, what we have here available to us is point clouds, or rather LIDAR data, of this entire section. And this is what it looks like. So these are, I think, about 650,000 points in this 400 by 400 meter area, color-coded by elevation ranges of the bare earth and as well of the treetop layers instead, so with the vegetation still on. What we do is we take these point clouds and then we convert them into surfaces. So if I turn off my point clouds here, I'll note here this is just the treetop point cloud, and you can see, of course, where the vegetation has been removed. You can see the corridors quite clearly. Those are getting turned off, and the bare earth surface is going to be turned on. And basically what we do there is turn the point clouds into a tin model so that we can actually do some calculations with them. And so we can see in the vicinity of our proposed lease that we have an elevation gradient coming from south to north, with south being higher and the north being lower. And the nice thing about AutoCAD being that we can list the elevations in our area. So this is, for example, 831.8 meters, and to the south 836.6 meters. Now, to actually lay out the lease here, what we're going to do is we're going to do a bit of modeling. What we have over here is a typical well layout. Now, under the Sustainable Resource Department's EAP application requirements, the maximum size of a lease for a single well is 130 by 130 meters. That's delineated by this red polyline here. This white polyline delimits a 40 by 80 meter typical well pad. This is the minimum leveled area required to get a drilling rig on and to be able to drill. The slightly pinkish P line is a 15 meter offset from this outer limit of the lease boundary, which approximates what will be the eventual leveled out area of the lease. What we also see is we go further out to model our cuts and fills, and this is best seen in an orbit. We're limiting ourselves to a 1 to 3 slope on our fill section of the lease and a 2 to 1 slope on the cut sections. So what we'd like to do is we'd like to take this model of a lease, put it beside that Apache lease, and figure out what's the ideal elevation for the well center as to maximum, or rather minimize, the difference in cut and fill so that we're not moving dirt around. As well, we have to ensure that the disturbance is limited to the well area. So, as you can see in three-dimensional space here, what we have is we have the lease itself. So the red polyline again is the boundary of the lease, and then we model what it would look like to go at a 3 to 1 or 2 to 1 slope away from that, away from the leveled area, which is the pinkish polyline. So that's our lease. To actually now model and put it beside the Apache lease is relatively straightforward. All we're going to do is we're going to grab all these points and align them against the boundary of the pre-existing lease, because we of course have to be contingent, coincident, and parallel to all existing dispositions. So here we're going to grab this edge and we're going to put that here. And then we're going to take this edge and we're going to snap it to here. So we would like our lease to look something like that, parallel, as I said, to the pre-existing Apache lease. Now let's turn off the surfaces here. So we're looking like this. The other thing we have to know is, of course, how high up do we need to move our lease to be, and the appropriate initial estimate will be to raise it to such that the well center is at the same elevation as the native earth, so that the well center is at the break between cut and fill, which we can see here is at 832.56 meters. So I'm going to raise this entire pad up to that level. And then what we're going to do is move this so that the well center elevation moves up to 832.56. And then, of course, now that the well is up at the correct place, what we have to do is we simply have to create a deviation surface showing what the cuts and fills are. So to do that, what we'll do is we'll create a new surface where we compare cut model, the difference between the bare earth or ground with then our well site model. So for example, in this case, the model where we go into the cut. Okay, it calculates some things, and if we show this as contours, what we see here is we see what the deviations, let's show those at the meter level, from a well where a cut comes from this boundary upwards is compared to the actual surface here. And most importantly, if we put our cursor over any one of these lines, what we should see is what the actual cut and fill at those particular points are. So this is our 0 cut surface, this is a 1 meter, and so on and so forth. This is going to be very important. Let's extract this 0 contour, because this is going to be where we transition from cut into fill. And to do that, we'll go modify surface, and extract from the cut model that contour, like so. And then what we're going to do is we're going to use that contour as a boundary. And so what this shows you is to have a 1 to 2 cut on our lease. All we need is to cut in this area here. So that's how far off of lease one has to cut. We'll do the same for the fill here. Surface. Call this the fill model. Again, we're going to be comparing the ground. It's to the fill surface. It calculates its magic. And we'll see these contours. Okay, so this time around, this is how the fill onto the surfaces would look. And what we should see here, that's the 1 meter fill. This is the 0 meter fill. Again, what we're going to do is extract that, which comes around like such. From the fill model. There we go, okay. And let's use this as now a boundary for our fill model. Alright, so what we can see here is that if we wish to maintain our slopes, what we'll have to do is we'll have to level this whole pad off and then cut in this amount and fill in this amount, and we will maintain the elevations that we need to maintain. So what we end up learning from this then is, if we take a look at our contours, this is our cut fill line. If we hover over this contour here, we end up knowing that at the edge of the lease we have about 1 meter of cut that is required on this side, and we have about 1 meter of fill that's required on this side before we even out and hit back to natural ground. Let's next try to calculate what the total net cut and fill volume is. And before I do that, I'm going to turn off this bare earth model, just so that we can better see what's going on with cuts and fills. Okay, so then to continue to figure out the volumes here of the cut, all we simply do is go into our analysis. We're going to calculate some bounded volumes. First on the cut side. So we want our datum elevation to be 0, and the bounding polygon is this. And what we can see down here is that to put this lease such that the entire green area is leveled, or sorry, rather that the entire pink area here is leveled out, we'll have to cut 1 meter in this area here, and it'll be a net cut, or rather just a cut, of 3,700 cubic meters. If we do the same analysis on the fill, so we're going to analyze fill model, datum of 0, and this time this is the bounding rectangle, we see that we have 3,103 cubic meters of fill. So that gives us a net cut of 629 cubic meters. What we can also do is we can list the area of these polylines. So the fill area is 5,400 meters squared. The cut area is 5,600 meters squared, which means that we would have to raise this lease by about 2 centimeters to equalize cut and fill. So in this case, not worth the hassle. However, some things we might be interested in are, for example, to widen out the area. If we did not want to have a 15-meter topsoil storage buffer, for example, we could move north, south, east, west this boundary until so long as this green line here doesn't go outside of the red lease boundaries, because we of course don't want to do any, or are not allowed to do any earthworks outside of this boundary. So through an iterative process we can find the largest lease that can fit on a particular 130 by 130 square, and as well calculate what the net cut and fills are. And so then, as I said, we could for example change the display as well to increase the number of contour lines on both the cut and the fill model, so that you now have a very nice diagram of exactly here we would have increasing amounts of cut required. So the edge of this lease, for example, here sits in 1.8 meters of cut, coming out to 0 meters of cut where it intersects the land. On this side, the edge of the lease is sitting on top of 1.39 meters of fill, going down to 0 where it meets here. And then you have your map across the entire lease. One of the interesting things then, of course, is if we decided that we wanted to, for example, have more cut material because we wish to transport some material for borrow somewhere else, or for example to pad up an access road or such, it doesn't take us very long to, for example, drop the entire lease and recalculate these contours. Basically, what is involved is we turn off all of our surfaces, drop all of our points, say for example another meter. Let's move our cut points here. So we're going to drop the entire lease for 1 more meter. So first thing I have to do is select all the points that comprise my model, although this could be turned into a block. There we go. And then all we're going to do is we're going to drop all the points for 1 meter and recalculate contours and see how the extents of the lease have changed. So for example, at 0, 0, let's drop it for 2 meters. We'll refresh this. We'll refresh our point groups. And then all we have to do is refresh the models, rebuild, 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 and rebuild. Now, if we take a look at our cut model, and we take a look now where the 0 line extends to, 2 meters, 1 meter. So now we see that this was the old 0 line. Now since we've dropped the entire lease, we see that in fact the entire lease is actually in cut for all intents and purposes. So if I modify the surface, by extracting out of the cut model, the 0 contour, which is this one here, and then using this as the boundary, we'll see exactly that the entire, we can delete this, this was the old fill boundary, this was the old cut boundary, and we see now that the entire lease is actually in cut. And we could calculate a total volume quite simply of, if I wanted to see even what the contouring was on that cut. We'll just change it here. And we'll see now that the entire lease gets cut and the entire volume is now going to be cut model. 0, and select the bounding polygon. we're going to have 23,000 cubic meters